Good morning, students. In today's session, we are going to perform a laboratory experiment of concrete technology. So, let's get started. So, today we are going to see experiment number 11, which is workability of concrete. So, now we will see what is the aim. So, aim is to determine the workability or consistency of concrete mix of grade M20, which is having the ratio of 1:1.5:3, proportion by compacting factor test. We will see the apparatus and materials required. So the first one is compacting factor apparatus, second one is weighing balance, third one is trowel, fourth one is stamping rod, fifth one is mixing tray, the next one is cement, sand, aggregate and water. Now we will see the theory behind it. So, the compacting factor test is designed primarily for use in the laboratory, but it can also be used in the field. It is more precise and sensitive than the slump test and is particularly useful for concrete mixes of very low workability, as are normally used when concrete is to be compacted by the vibration. The method applies to plain and air-entrained concrete made with lightweight, normal weight, or heavy aggregates having a nominal maximum size of 40 mm or less, but not to the aerated concrete or no fines concrete. It is based on the definition that workability is that property of concrete which determines the amount of work required to produce full compaction. The test consists essentially of applying a standard amount of work to standard quantity of concrete and measuring the resulting compaction. The compaction factor is defined as the ratio of the weight of partially compacted concrete to the weight of fully compacted concrete. It shall be stated to the nearest second decimal place. So now we will see the table which is indicating the degree of workability, slump, the value of slump in mm, the compacting factor for small apparatus, for large apparatus, and use for which concrete is suitable. For example, for low degree of workability, the slump value is 25 to 75 mm. For small apparatus, it is 0.85. For large apparatus, it is 0.87. And the use is the rods vibrated by hand-operated machines. At the more workable end of this group, concrete may be manually compacted in rods using aggregate of rounded or irregular shape, mass concrete foundations without vibration, or lightly reinforced sections with vibration. Similarly, for medium, high, and very high concrete, you can refer the table. So now we are going to see the diagram of compacting factor apparatus. It consists of upper hopper, which is indicated by A, lower hopper, which is indicated by B, and the cylinder, which is indicated by C. Now we are going to see the procedure behind this experiment. The first point is thoroughly clean and grease the inner surface of the hoppers and the cylinder. Fasten the hopper doors. Then weigh the empty cylinder accurately, which is indicated by W1. The next step is to fix the cylinder on the base with ply nuts and bolts. Prepare fresh concrete of desired mix proportion. freshly mixed concrete in upper hopper gently with trowel without compacting. The next step is to release the trapdoor of the upper hopper and allow the concrete to fall into the lower hopper, bringing the concrete into standard compaction. The next step is immediately after the concrete comes to the rest, open the trapdoor of the lower hopper and allow the concrete to fall into the cylinder, bringing the concrete into standard compaction. Then remove the excess concrete above the top of the cylinder by a trowel. Then weigh the cylinder, that is cylinder filled with partially compacted concrete indicated by W2. Next step is to refill the cylinder with same sample of concrete in 4 layers, tamping each layer with tamping rod for 25 times in order to obtain full compaction of concrete. Then level the mix and weigh the cylinder filled with fully compacted concrete indicated by W3. Now we will see the observations. So for M20 grade of concrete, which is having the proportion of 1:1.5:3, the first observation is weight of the cement is equals to 4 kg. The second one is weight of the fine aggregate taken is 6 kg. Weight of the coarse aggregate taken is 12 kg. Type of cement is equals to ordinary Portland cement. Then fifth observation is brand of cement is equals to Coromandel King. The room temperature is 29 degree. Weight of the cylinder, that is W1, which is equals to 7.32 kg. The next one, weight of the cylinder with partially compacted concrete, which is W2, it is equals to 19.23 kg. The next observation is weight of the cylinder with fully compacted concrete, which is W3, it is equals to 20.25 kg. Now we are going to see the observation table, which indicates proportions of water cement ratio, water, then cement, then fine aggregates, coarse aggregates, and compacting factor. So as per observations, for water cement ratio of 0.8, we have got the value of water which is 3.2 liters. For M20 grade of concrete of proportion 1:1.5:3, we have got cement which is equals to 4 kgs, fine aggregate is equals to 6 kgs, and coarse aggregate equals to 12 kgs. So finally, for water cement ratio of 0.8 and M20 grade of concrete, we have got the compacting factor of 0.87. Now we will see the sample calculation. So the formula for compaction factor is equals to W2 minus W1 divided by W3 minus W1, which is equals to 19.23 minus 7.32 divided by 20.25 minus 7.32. So we have got the calculation which is 0.87. Now we are going to see the result. So the result is the compacting factor for water cement ratio 0.8 is 0.87, which indicates low degree of workability.